Hey folks, I thought you would benefit from an actual mini video on the answers to the problems in quiz 10 that you had to write regular expressions for. So here you go. If you just want the answer, I'm going to post the answer in the announcements. Now this Turing machine, which appeared in a number of questions on quiz 10, was not meant to be a trick question. It really was not. But the fact that somebody asked me about it and my quick glance at it gave the wrong answer means it, I guess, was trickier than I thought. And of course, the problem here, the biggest problem here, is that left is there, and we're not necessarily used to seeing a loop that says to go to the left on the same places we have a loop that goes to the right, right? So I think that caused people some problems. The other thing that I think caused people problems was just writing regular expressions. Please, please, please go back and review how to write regular expressions. Okay, so let's take a look at what happens on this machine. If we see an A and we're in state 0, we write an A and go right, and we just keep doing that. If we see a B, we write a B and go left. And if we see a lambda, we just stay put, right? We write a lambda and stay put. So let's look at a couple of examples. And these were actually examples that were in quiz 10 as just multiple choice ones, because I was hoping that maybe they would help you understand this Turing machine. So question 4 asked, does it accept the string ABC? So we have A, B, C on our Turing machine. Our tape head, of course, starts at A, because always in our model of a Turing machine, we start the tape head on the first symbol in the string. And all of these other cells that I'm not filling in are, of course, lambdas, because we also agreed that we were going to do Turing machines that way. So let's see. We start on the A, right? And we're at state 0. It says, if you see an A, write an A and go right. So we cross this out, and now we're at the B. And now this tells us, if we see a B, write a B and go left. So that sends us back here. But of course, if we see an A, we write an A and go right. So we go here, A, B, A, B, A, B, A, B. So this particular example, we just flip back and forth between the A and B. And we never make it to the halt state. And remember, the magic of Turing machines is you win if you get to the halt state, and if you never get to the halt state, you never accept, right? So we can actually forget about the C here, even though there's no C on here. We don't care. So I think a lot of people probably said, no, it doesn't, because there's no C in this Turing machine. But the truth is, no, it doesn't, because it just keeps bopping back and forth between that A and B. Okay, so at this point, the next question, question 5 asks, does it accept the string BCA? So let's draw that. We've got BCA with lambdas on the left and the right. And we start with our tape head on the B. And with our tape head on the B, the machine says, if you see a B, write a B and go left. So we replace that B with a B, we go left. Now we're at a lambda. Since we're at a lambda, we take this transition, we write a lambda, we stay put. We get to the halt state, so woohoo, yes, we do accept this. And this was supposed to try and walk you through. I thought I was giving you really helpful questions. But anyway, this was supposed to lead you to look at this and say, oh, wait a minute, if I see a B, I go left, I end up at the halt state. And once I'm at the halt state, I win, so who cares if there's a C in it or not? Right, now let me see, were there any more? Yes, I asked you if it accepted the string CB. So, hang on. So, if we're looking at the string, what did I just say, CB? Right, tape head starts here. We see the letter C. There are no transitions that let us do a C, right? So, boom, we're done. We fall off the Turing machine. We cannot do anything else, right? We're stuck. And so CB fails. The last string I asked you before I asked you what, to give me a regular expression for this, whoops, was AB, AB, AB. And again, the idea here was you were supposed to notice that, oh, look, it goes to A, then B, then A, then B, then A, then B, and it's in an infinite loop. It never stops, okay? So in answer to the question, what does this accept? Well, it certainly accepts any strings that are in A star, right? But it also, can I move this over a bit? There we go. It accepts A star, but what you also were supposed to notice was, check it out, if you have a string that starts with a B, you can have anything after that, right? So if it starts with a B, you can have A plus B plus C star after it, right? And that's why I said don't forget that there's a C in this language. Okay, so that was problem 1. Let's do problem 2. No, sorry, this one was problem 8. Let's look at problem 9. So in general, people did a much better job on problems 9 and 10 than they did on problem 8. For problem 9, you just basically have to look at this and see what's going on here. You can have as many A's as you want and go to the right, right? So you're just moving to the right as usual. If you see, then the next letter you need to see is a B in order to go to the right, and then you can see as many B's as you want, and when you get to a lambda, you can keep going. So how do you get to the halt state in this one? Well, this one is pretty straightforward. You can see as many A's as you want. You have to see a B to transition to state 2, and then you can see as many more B's as you want, and then you end up at the halt state. This last machine, I think people who had, I got the impression, and I'm not sure, but I think that some people had trouble with this one, not because they had trouble understanding the machine, but they had trouble expressing as a regular expression what this machine did. So please, please, I beg of you, go back and rewatch the regular expression videos, because I guarantee on the final there's going to be something that's going to ask you to write regular expressions. Okay, I don't totally guarantee it, but I'm pretty sure that there's going to be something that asks you to write regular expressions, and if you don't know how to write them correctly, then you're going to have problems. So let's look at this. We start, and really we are always moving to the right again. And as we process the string, we can process C's, or we could process sequences, pairs of A's and B's next to each other, right? Because if we just see an A, we get stuck here. But if we see an A and then a B, we're back here, and we can eventually get to the halt, right? And so the regular expression that represents this, there's a ton of regular expressions that represent this. The simplest one is either you see a C or you see the AB pair, and you can see as many of them in whatever order you want. So you could say C, 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 A, B, C, A, B, right? Yeah. Or you could see just C's, or you could see A, B, A, B, A, B, whatever. You with me? Or you could, in fact, see lambda, and that covers everything. Some people wrote this as C star, A, B star, and then the whole thing starred. That's perfectly fine too, right? So there's lots of variants that you can do on this, but again, you need to understand the regular expression, right? This plus, remember, means pick one of these, the first one or the second one, but then you can do it as many times as you want because I have the star here. Here I say 0 or more C's followed by 0 or more AB's, and you can do that 0 or more times. So even though there's not a plus in here, it gets away with it because you could choose to not use some C's or AB's sometimes when you go through that. So I hope this helps. Please go back, review regular expressions, review Turing machines.